Welcome to Math with Professor V. Today we're diving into rational function integrals, specifically the ones where long division has to happen before you break out the partial fractions. Trust me, this step makes all the difference. So how do you know when you need to long divide first? Well, say you have a rational function of the form f of x, which is p of x over q of x. And the degree of q of x, so the degree of your denominator, is less than or equal to the degree of p of x, the numerator. That's when you need to long divide first. After that step, you can perform partial fraction decomposition on the remainder, only if it's necessary to integrate. And I've got 5 examples for you to walk you through this process. That way you'll be integrating rational functions like a pro. And let's just jump right in. Okay, first one, we have indefinite integral 3x to the 4th plus 15x squared plus 5 over x cubed plus 5x dx. Right away I notice, I'm going to need to start off with long division because the degree of the numerator is 4 and the degree of the denominator is not more than 4, it's lower, it's 3. So to start off, let's long divide. If you need a refresher on polynomial long division, I have a video. I'll link it here. Top right, you can click, and it's also in the description. Now, it's up to you if you want to put zeros or just leave spaces, but we need placeholders because there's no x squared term. And then here's 5x, okay? And then I'll just put another plus 0 for the constant. So depending on how you were taught, you might just leave spaces, or you could put the zeros with the placeholders. That's how I was taught. And then here, we're dividing that x cubed plus 5x, the denominator, into the numerator. 3x to the 4th plus, we need a 0x cubed, plus 15x squared, plus we need a placeholder 0x plus 5. So now only look at the leading terms and think to yourself, what do I need to multiply x cubed by to make it 3x to the 4th? Why, yes, 3x. Very good. Then you take that result and you multiply it through the divisor, the whole thing, and you list it underneath. So now this is going to be 3x to the 4th plus 0x cubed plus 15x squared plus 0x. And we subtract this from what's up above. So these will cancel. This is gone. Ooh, bonus, these cancel. This is nothing. And then now I bring down what's left over, which is the 5. And then now at this point, my long division has come to an end. How do I know? Because my divisor, this whole thing's the divisor, is degree 3, which is higher than what I'm trying to divide into. So then I know I'm done. This is now my remainder here. Okay. So what do we have now? Well, I can rewrite this integrand. We have integral now of 3x, that's part of my quotient here, plus 5 over the divisor. Now I'm not going to write it with all the placeholders. I'm going to write it how it originally was right here, x cubed plus 5x dx. Good? Okay, so now when you look at what we've got, this 3x we can find the antiderivative of, no big deal. And then now the remainder, notice the remainder is in a form for which we can find its partial fraction decomposition. The degree of the denominator is 3, which is higher than the degree of the numerator. Make sense? My pre-calc teacher used to say, before you do partial fractions, you need a J-low fraction. It needs to be bottom heavy, higher degree in the denominator. Okay, so it's partial fraction time. Let's go. We always have to factor the denominator first. So x cubed plus 5x, the only thing we can do is take an x out, which is fine. So we've got x times x squared plus 5. So be careful. Your decomposition will have 2 terms when we started off setting it up. X in the denominator of 1 and then x squared plus 5 in the other denominator. X is just a linear factor, so we'll have constant a up top. X squared plus 5 is irreducible quadratic, so then we'll have bx plus c here. And then multiply everything through by the least common denominator or least common multiple, x times x squared plus 5. So you want no fractions now. And then we'll have 5 equals a times x squared plus 5 plus bx plus c times x. Good? So 5 equals ax squared plus 5a plus bx squared plus cx. And then now to solve for the constants a, b, and c, I'm going to equate the coefficients of like terms on both sides of this equation. So starting with the highest degree, x squared, I don't see any x squareds on the left. So 0 has to equal a plus b. X to the first, I don't see any x's on the left. So 0 has to equal c. And then x to the 0, or constant terms, we have a 5 on the left, which equals 5a. So boom, that tells me a is 1, and then based on that, b has to be -1. Perfect. So now we can rewrite this expression using our partial fraction decomposition and evaluate the integral. So now we have the following. Integral of 3x plus a is 1 over x, and then b is minus 1x over x squared plus 5 dx. Okay? And then from here, we should just be able to go term by term. So antiderivative of 3x is 3/2 x squared. Antiderivative of 1 over x is ln absolute value of x. Minus, now depending where you're at in your calculus career, you may or may not need to do u sub here. May or may not, meaning you may need to write it out, or you might be able to just do it in your head. But that's what's happening is a u sub. So if you're going to write it all out, u would be x squared plus 5. du would be 2x dx. Since I just have x dx, I'm going to pick up a 1/2 when I integrate. Okay, and I'm not going to write out the full u sub. You can finish it off if you need to. But I know I'm going to have 1/2 ln of the denominator. Now, since x squared plus 5 isn't negative, I'm just going to put parentheses instead of absolute value. I don't need absolute value. And then don't forget plus c. So we're done. How was that one? Good, right? Okay, let's look at another situation. Right off the bat, I can tell I'm going to need to long divide because degree of the numerator is 3, degree of the denominator is just 2, okay? So here we go. X squared plus 4x plus 4 is my divisor. You take the denominator and you divide it into the numerator. So we have x cubed, I'll put plus 0x squared plus 0x plus 0. All right, only look at the leading terms. What do you multiply x squared by to make it x cubed? Just x. Then that x distributes through the divisor and you write the result underneath. So this will be x cubed plus 4x squared plus 4x. And then subtract that from the row above. So this furthest entry on the left should cancel out, otherwise you messed up. And then this is minus 4x squared minus 4x. We can bring down the plus 0, sure, why not? Okay, then you repeat the process again. Just look at negative 4x squared and x squared. What do you multiply this by to make it negative 4x squared? Why, negative 4. Then that distributes to the divisor and you write the result underneath. So this will be negative 4x squared minus 16x minus 16. Good? Then we subtract that from the row above. This should cancel. Negative 4, be careful, plus 16 is 12x. And then this is positive 16 now. Now this is my remainder. How do I know that? Because this is degree 1 and my divisor is degree 2. It's higher, so I can't divide it into something of lower degree. So we are done. So now how would you rewrite your integral? Well, you would write it as follows. So you have your quotient, which is sitting up top right here, minding its business, x minus 4, plus the remainder right there, 12x plus 16, over x squared plus 4x plus 4 dx. Good? Okay, perfect. Now. what would you do? You could do partial fraction decomposition for the remainder here. I'm going to show you how you can kind of manipulate it to avoid partial fraction decomposition. Not that it's bad to do partial fraction decomposition, it's just sometimes tedious and repetitive. So sometimes you might want to spice things up or do things more efficiently. So let me show you what you could do. Okay, let me rewrite things as follows. So we've got x minus 4 plus, that'll be its own little integral. How about that? Plus x squared plus 4x plus 4. Hopefully you recognize this is x plus 2 quantity squared, right? Okay, so what I like to do is go like this. You have 12x plus 16 over x plus 2 quantity squared dx. And I think to myself, oh, life would be so nice if I had like an x plus 2 up here so that I could cancel with the x plus 2 down there. Well, I'm going to need to factor this 12 out. If this was a 24, I'd be in business. So what am I going to do? I'm going to make it happen. I'm going to make this 16 a 24. So you can't just willy-nilly go changing things around, right? Illegally. The math police are going to come snatch you. But in order for 16 to be 24, I need to add 8. And then I'm also going to subtract 8. That way, all I've done is add 0. Nothing illegal is happening. No tickets for me from the math police. Okay. So here we go. Integral x minus 4 dx plus, now this is 12x plus 24 over x plus 2 squared dx minus 8 over x plus 2 squared dx. Are we all right? So this 16 plus 8 is the 24 here, and then this minus 8 is over here. All right, we've got 3 little integrals. You can knock them out all at once, but I'll just break it down and do them separately for you, okay? Everyone's probably at a different place in their math journey. So integral number 1, x minus 4 dx. We got this, no problem. 1/2 x squared minus 4x. I'm going to say plus c1. I'm going to save my final constant c for the very end of the integral, okay? Number 2, integral of 12 times x plus 24. Let's factor out the 12. Then it's just x plus 2 over x plus 2 squared dx. So what's this going to give me? Oh, something so fabulous. This cancels out, right? So then it's 12 times the integral, basically 1 over x plus 2 dx, which is 12 natural log, absolute value x plus 2 plus c2, very good. And then my third little integral, I'll put the negative back in later. How about that? We have 8, let me write it as x plus 2 to the negative second to kind of help you. So when we integrate, we add 1 to the exponent, divide by the new exponent. So it's going to be negative 8 times x plus 2 to the negative first plus c3. Or negative 8 over x plus 2 plus c3. So then now let's put it, and then tell the people that's what's happening. All together, we have 1/2 x squared minus 4x plus 12 ln absolute value x plus 2 minus negative 8 over x plus 2. So plus 8 over x plus 2 plus c. And then tell the people c is c1 plus c2 plus c3. And yes, you should be this precise with your constant from integration with the c. Keep track of it, rename it as it evolves. This is going to be very important if you move on to take differential equations and other math classes. So I don't want you having sloppy habits now and then having to unlearn them later on. You know, that's more difficult. So just start off doing things correctly from the get-go. That's what we like. All right, shall we move on? Yes, Professor V. Okay, great. So here we go. We've got integral x to the 4th plus 9x squared plus x plus 2 over x squared plus 9 dx. Why don't you pause the video, try this one on your own. See how you can do it with the long division and the rest. It's actually not so spicy. I think you can do it. Okay, did you try? I hope so. So x squared plus 0x plus 9 into x to the fourth plus 0x cubed plus 9x squared plus x plus 2. All right, again, what do you multiply x squared by to make it x to the fourth? X squared. Then distribute the x squared to the divisor, so that'll be x to the fourth plus 0x cubed plus 9x squared. Subtract. This cancels. This is nothing. This cancels. Wow. So we just have 0 and then bring down x plus 2. Now I'm done. This is my remainder because this is degree 1. My divisor is degree 2, so I can't divide any further. So now let's just rewrite our integral. We have x squared plus the remainder, x plus 2, over the divisor, x squared plus 9 dx. Good? Okay, now look at this rational expression here. We don't have to do partial fraction decomposition. The denominator just has one factor, an irreducible quadratic. You're just going to split it into 2 terms. It's ready to go. It's less work than you think. Watch this. X squared plus x over x squared plus 9 plus 2 over x squared plus 9 dx. Boom. Wow. So what would you do for this term here? You would do a cute little u sub. You could write it out, or you could just do it in your head. U would be x squared plus 9. Du would be 2x dx. So I know I'm going to pick up a 1/2 because all I have is x in the numerator, not a 2x, right? And then this guy, hopefully you have memorized when you have integral of 1 over x squared plus a squared dx. It's 1 over a tan inverse x over a plus c. So in this case, my a is 3. Can you see that? Because 9 is 3 squared. So a is 3. And then you might say, well, what about this 2? Pay it no attention. It's just going to come along for the ride, come outside the integral. Just bring an extra 2 in your final answer. Okay, so I think we're ready to put it all together, right? Antiderivative of x squared, 1/3 x cubed, plus, this is going to be 1/2 ln the denominator, and I don't need to put absolute value because x squared plus 9 is not going to be negative, plus, so normally you would have 1/3 tan inverse x over 3, but I'm going to have 2/3 tan inverse x over 3. 2/3 tan inverse x over 3 plus c, and then box it with pride. Yes, that was a job well done, everyone. Good. Did you do the long division part okay? No? Yes? Let me know. Okay. I told you we've only got 2 more. Ooh, they're fun. I like them both. Okay. This one. Maybe you wouldn't immediately notice it needs the long division, but it does. Why does it need long division? Because degree of the numerator is equal to the degree of the denominator. Remember, you can't do partial fraction decomp until it's bottom heavy. Higher degree in the denominator. This is not a J-lo fraction. So we must long divide first. Long divide x squared minus x minus 12 into the numerator. The J-lo fraction came from my pre-calc teacher in high school, Mr. Powers. He had a lot of funny stuff. He would call the asymptotes on the graph the MC hammer. Can't touch this. It was always a good time in that math class. I loved math. Always. Okay. What do you multiply x squared by to make it x squared? 1. Then you distribute that 1 to the divisor listed underneath, x squared minus x minus 12. Now we subtract. Goodbye. We have a positive x and then 5 minus negative 12 plus 17. That's all my remainder, right? This is degree 1. This is degree 2, so we're done. We're done dividing. So now we have integral of the quotient, which is just 1, plus x plus 17 over the divisor x squared minus x minus 12 dx. Are we all right? Oh, good. So now, yes, it is partial fraction time for the remainder portion, basically. So let's say we've got x plus 17 over x minus 4 times x plus 3. Those are both linear factors, so we'll have just constant a over x minus 4 plus b over x plus 3. Multiply through by x minus 4x plus 3. And what do we have? So we've got x plus 17 equals a times x plus 3 plus b times x minus 4. Now, when you have all linear factors like this, what's a nice way to solve is you substitute in values for x that will make each of the factors 0. So I'm going to start off by substituting in x equals -3 everywhere. If you haven't seen this, it's great. So on the left-hand side, that would give me 14 equals a times 0 plus b times -7. So if -7b is 14, that means b is -2. And then do the same thing. Now I'm going to substitute in x is 4. So on the left-hand side, I'll have 21 equals a times 4 plus 3, that's 7, plus b times 0. So a is 3. Woohoo! Okay, so now we can rewrite everything nicely with our decomposition. We have integral of 1 plus a is 3 over x minus 4, b is -2 over x plus 3 dx. Don't forget the dx. And then just go integrate term by term. So antiderivative of 1x plus 3 ln, don't forget absolute value, x minus 4 minus 2 ln absolute value x plus 3 plus c. It's up to you. I wouldn't really find it helpful or aesthetically pleasing to combine these into a single logarithm. I'm just going to leave it. I think it looks great. Don't you? Okay, last one is easy breezy, but you got to remember how to factor a sum of cubes. Do you remember? If not, I have a video on it. I know. I have videos on pretty much everything. If you need to review some of your basics, then check out the Intermediate Algebra video lectures playlist, Pre-Calc video lectures playlist, Trig. I even have a whole playlist, Algebra Review for the Calculus student, where I just hone in on the algebra topics that you use throughout calculus and show how you put them into practice in your calc classes. So that might be where you need to go. Okay, would you know right off the bat we got to do long division? Yes, because it's not bottom heavy, right? Degree is higher in the numerator. So let's divide x cubed plus 1, but I need a whole bunch of placeholders. Do we need placeholders in the numerator? We sure do. X to the 5th plus 0x to the 4th plus 0x cubed plus 0x squared plus x minus 1. Great. All right, just focus on the leading terms. What do you multiply x cubed by to make it x to the 5th? X squared, then distribute the x squared. So we'll have x to the 5th plus 0x to the 4th plus 0x cubed plus x squared, and then subtract. Goodbye, gone, gone. Negative x squared plus x minus 1. Can I keep dividing? No. This is degree 3, this is only degree 2, so we're done. Okay, so now we have x squared plus my remainder, negative x squared plus x minus 1 over x cubed plus 1 dx. Okay, now at this point you might start gearing up to do your partial fraction decomposition for this remainder, which is fine. However, you have to remember how to factor x cubed plus 1, a sum of cubes. And it factors into x plus 1 times x squared minus x minus 1. Did you remember that? If not, check out my video on factoring a sum and difference of cubes. Now here's where the magic happens. So we've got x squared And I want you to look carefully at this expression here, this factor, and what I have in the numerator. They're almost identical, right? Just all the terms are off by a sign. So what I'm going to do is factor out a negative in the numerator, and instead of writing plus, I'm actually going to put minus. Don't freak out. And then we've got x squared minus x plus 1 up top. Are you all right? Yes? Okay, good. Now downstairs, we've got x plus 1, x squared minus x minus 1. And then, lucky for us, those will cancel, and we don't even have to fuss with finding partial fraction decomposition for that remainder. See? Ba-boom. Those are gone. I love it when things simplify unexpectedly and leave you with even less work than you had thought. So now we just got to do x squared minus 1 over x plus 1. Oh, how cute. Okay, antiderivative of x squared, 1/3. X cubed minus, this is ln, absolute value, x plus 1 plus c. And we are done. Done, done, done. All right. So that's it. That was the 5th and final example. I hope you found this video helpful. I've had a few people ask me to do specifically this topic. Just be advised, like when you're given integrals on an exam, most likely they're not going to tell you. And these are going to be mixed in with other rational functions that you're integrating where the denominator already is of a higher degree and you can just jump straight into partial fractions. So you're just going to have to recognize when this happens. If it's not bottom heavy, long divide first, okay? That's my piece of advice. I hope you found the video helpful. Please don't forget to give it a thumbs up. Leave me a comment below which of the 5 was your favorite. I think the last one. I saved the best for last, didn't I? And if you need to review any of your other topics in math, or if you just want to see more video lectures, I have the full course for Calculus 1, 2, and 3 on my YouTube channel, as well as differential equations. I have some linear algebra videos if you're a channel member. And don't forget to follow me on Instagram and TikTok, Math with Professor V. I'll be back sooner than later. Thank you guys so much for your support. Love you all. Bye.